We talk about web-based UI tools on this channel quite a bit, but Rust can also power native desktop UI, as proven by the Iced project. Iced 0.10 is a big update for Iced, but I'll be assuming you don't know what Iced is in this video, and instead focus on an overview of the project as it stands. Landing on the Iced website, there are two places that you can start, the guide or the API reference. The API reference is the docs.rs page, while the guide is, incomplete. However, the guide does point us to a number of important places. Back to the API reference on docs.rs, the official examples, which live in the GitHub repo and is very common practice for Rust projects, and Awesome Iced, an awesome list for Iced projects that is officially maintained. First and foremost, Iced is a desktop-based application framework. They do say cross-platform GUI library here because it can compile to WASM and run on the web. However, the major use case I see for native capable WGPU-based applications is running on the desktop. It claims to be inspired by Elm, which makes a lot of sense if you look at the docs.rs. They continue to say that Iced is focused on graphical user interfaces, so it's not really a TUI-based or terminal-based framework that you can use. And it's strongly focused on simplicity and type safety, which very much matches the Elm idiom. Overall, the features list out that it's a GUI framework. It's got widgets or components, it's got cross-platform support and responsive layout. You can create your own widgets, and it's type safe. For me, the only huge call out in the docs right here is the modular ecosystem. And right away, they make it clear that Iced is meant to be used by two different types of users: end users building applications themselves, and GUI toolkit developers or ecosystem contributors. These are people that would be building widgets for other people to use or integrating Iced inside of, say, the Bevy game engine or something like that. We'll be talking about the native side of things today, so you can roughly split that into renderers and shells. That is something like Winit to manage Windows and something like WGPU to render graphics. There's a software-based renderer that's called out in the README that isn't in this document that we just looked at above, detailing the ecosystem. That's because the software-based renderer is fairly new, and it can be used as a fallback. It's worth pointing out that Winit is the window management library that is also used by projects like Bevy, so it is a widely used Rust ecosystem dependency, as is WGPU, which is not only used in Firefox to power WebGPU for the web, but also inside of Bevy and other projects. So let's get around to looking at what Elm-like means, or what it looks like to write a very simple counter. There are 4 callouts in the docs: state, messages, view logic, and update logic. Each of these is sort of cordoned off into its own world. So let's start with state. State is just regular structs. In this case, we have a counter struct that has a value that is an I32. I'm going to scroll down a little bit further than you might expect to take a look at the view, because I think how you declare views and how you declare your application and the way it looks is fairly important. So we impl counter and provide a function called view. This takes a mutable reference to self, that is the counter, and returns a column message. We have these macros that can do layout in either a column direction or a row direction. And inside of those macros, which look somewhat like arrays, we have more components or more widgets, whatever you want to call them. In this case, we've got a button, we've got some text, which has the value of the counter, so self.value, and another button. There's event handlers on each of the buttons, for both for incrementing and decrementing, and we can set attributes like the size of the text. These are all built-in widgets that come from Iced widget, and even if you're not super familiar with Iced, this should seem fairly straightforward. We've got what is basically a vec or an array of a couple elements laid out in a certain way that have certain attributes. You'll notice that when we onPress, we send messages. So in this case, we've got message increment pressed and decrement pressed. This is a regular Rust enum, so we've got a regular Rust struct for state and a regular Rust enum for messages. These messages carry data that we then need to update our state or application with, which we can then re-render. In this case, we aren't carrying much data, just whether we should increment or decrement. So we do need this update function as well to be able to actually respond to these messages. So when a message comes in, we have a mutable reference to self, in this case counter, which is effectively our application type at this point, and the message that came in. If you've used fold or reduce before or worked with something like Redux, this should look fairly familiar. We match on the message and we do something to the state, and then it's updated. So basically we have this application that has some view logic for displaying things like buttons that the user can interact with, that updates itself by passing messages to this update function, which then modifies the state, and so on and so forth. That brings us to the Tor. I've chose the Tor because the Tor is roughly 700 lines of code, if I remember correctly. Yeah, 700-ish lines, but it doesn't contain any unique logic. I don't need to explain anything out of the ordinary if you're familiar with Rust. It's important to note that this Tor is the Tor from inside of the Iced repo, and that other than Iced, it only has one dependency, nflugger. I would probably use tracing personally, but use what you want. And today we're going with whatever the example wants. As far as features go, we're using the image feature and the debug feature. This is because we intend to render images, and also because the tour will show us some of the debug tooling. We've got a Ferris.png image, an index.html that we aren't going to touch, although it uses trunk if you're familiar with Wasm builds in Rust. And then we've got our application. So we start off with this page that says welcome, some paragraphs, and then a next button. So the way that this works is you can click these buttons, go next and back. So there have to be some kind of event handler. There has to be some way of us getting from one page to another. This kind of shows one complete set of UI and then switches to another complete set of UI. So let's take a look at how we get started here. As usual, we'll start at the main function. The main function returns iced result, which is a very common idiom in Rust. Then we initialize the logger and we set Tor run. So Tor run takes a settings default, and we can see that we've defined Tor as a regular struct here. With two fields, it's got debug, which is true or false, and steps, which is a steps, which we'll see later. The TLDR for steps is that it's just a list of each of these pages. So we start out and we implement Sandbox for Tor. Sandbox is one of two traits that you can implement to get your application started. On the right here, we have Sandbox, and on the left here, you can see application. The big difference between these is that application lets you do async stuff and Sandbox doesn't. So the general recommendation of the iced project is to start with Sandbox and to upgrade to an application if you need to. Upgrading shouldn't be too hard. So we can see a couple of the functions that we defined earlier, new, title, update, and view, as well as the run function that we actually use to start our application, and the settings type that contains a number of settings for our overall application. This includes settings like the default font and the default font size, which in native land can't be taken for granted. On the web, we're very used to just having a default font size and default fonts and being able to load things all over the place, but don't take for granted the fact that fonts work here. So we choose to use Sandbox, which means we're not going to do any async stuff, and we define our message type to be message. If we look for enum message, which is where our message will be defined, we have back pressed and next pressed, which are these two buttons here, as well as step message. Step message is significantly more complicated and contains the logic for various different toggles when we're on each page. So we've got our message type, we've got the new function, which returns a new Tor with default values. We've got the title, which gives us the title. So up here it says welcome-iced. And then we've got our update, which takes the message and does things to the state, as well as our view, which defines what we should show. Update won't make too much sense. We're just matching on the message. And for back pressed, we go back, which is a function we define later on steps. For next press, we advance, which is also a function that we define on steps. And for step message, then we update each of our steps. Our view function controls how we lay out each of these pages, right? So if we click next, then a back button shows up, for example. And this is controlled by if steps has previous. The most sort of interesting thing about this to me is that this is regular Rust. It's an if expression. We call a function, we get a Boolean back, and then we've got this row macro for laying things out in a row. And if we have a previous, which is a function we define, again, this is on steps here, and the has previous function is just checking for an index of greater than 0. So if we have an index greater than 0, push a control into the controls vec, basically. In this case, it's a button that sends a message on press and is styled as a theme button, secondary button. You can do dark themes and light themes and all sorts of things, which we probably won't really get into today. Horizontal space features fairly prominently, so we control push this back button and then some amount of space in the middle here that just fills up the area. And if there's a next, then we want to also show the next button. Can continue is a little bit more complicated though, because can continue is not just a function, but also a field on each of these steps. So there will be conditions that determine whether we can continue or not. So that function is just a little bit more complicated, but it's only accessing the state of a step. Each time we use view, we use self.debug to determine whether we should show debug or not. We'll see why that is later. And then we set up a row for the content on top of each of the buttons. In this case, we're setting max width and spacing and padding and whatnot. And although it's not mentioned here or anywhere in the Tor at all, you can also do some responsive work. So overall, that's pretty much it. Each of these steps is something that we can also render out. So we've got step welcome and slider and whatnot. We're in slider right now. So the slider starts with a value of 50. And of course, steps also implements and uses update and view and things like that. The way these are implemented is by looking for a particular step in the vec and then calling the update function on that step. Step then is an enum for each of the sort of pages that we have. We define a step message, which is the message that we're using for each page, as well as the update function once again. So you can see this starting to get pretty repetitive. Define the view, define the update, define the message. Our view function is a little interesting. It's not super interesting. Basically, we call a function on step for every single page. And this is where I kind of get a little bit nervous seeing this. I would love to see this broken out a little bit more, because even though they describe it as being useful for simple applications right now, I'm not sure that this setup would grow beyond that. So each of these functions is a regular function that we also define on step. So container, for example, is just a column with some text and some spacing. So on the welcome page, if we go back, we can use self-container welcome, which passes the title in here and renders it at a size of 50, inserts some spacing, and then pushes a bunch of text in over and over. And then once we're on the slider page, we get a value from our state, as well as the step message type, because we passed that into everything that we are rendering, which allows us to create this slider from 0 to 100, which is a native widget, pass in the value we want it to be at, and use the step message slider changed message, which takes a U8. So there's a little bit of shorthand going on here, because step message slider change takes a U8, but we're not actually passing in a function that we then construct slider changed with here. Other than that, it's more of the same over and over and over. If we go to the next page, rows and columns, this will change the layout for these two buttons between a row and a column. And all this is a match on the layout state for this particular step. We again use a built-in radio button. We trigger and respond to the layout changed, and we do that by matching on the layout value, which either gives us the row macro or the column macro. Text can change sizes, but we already knew that, and it can change colors as well. Slight increment over what we just saw. This is where it gets a little bit more interesting for me personally. This is the radio button step, or the radio button example inside of the Tor, and it's where we get to use iterators. So language is our iterator here, and we've defined a function on all that will give us all of them. So there's 6 of them total, C, Elm, Ruby, etc. Clone the values, map over them, create a radio button for each of the values, and we create an element from each of those. So to render a selection of radio buttons, we get to iterate over some list and just create elements however we want to. This I really like. I really like leaning on Rust for iteration, because iterators in Rust are a really well-trodden territory. And I love that they didn't go with something that was a little bit more custom here. So if we click the right button, we get the next button. And if we click the wrong button, so say Haskell, because Iced is not written in Haskell, it's written in Rust, then the next button disappears. And this is the language selected step message. So if we look at the language selected, then our language comes in because we used radio buttons. And if we look at the update function, when a language selected comes in with a language, the selection gets set to some language. And this selection is coming in basically as a prop to our component. It may not be obvious at first why the next button is capable of showing up, but remember we call that can continue function, which we then call the steps can continue function on earlier when we're trying to render the next button. And if we're in the radio step, we get that selection and check to see if it's some language Rust. So the logic here is kind of spread out a little bit, which I don't love. The thing that triggers whether the next button should show up or not doesn't live where the next button shows up or not. It lives kind of somewhere else. But this continues over and over. So we've got a toggle button here. We've got an image here that can be resized. All of these work exactly the same way. We've got a scrollable area here. So this is about halfway, and then we scroll all the way down and we see Ferris again. We hit next, and then we get to inputs. Inputs allow us to type inside of, but one thing that is notably missing is I can't hit tab here and get through each of the text inputs. We can set password mode, we can show an icon at the end, and this is all implemented in the same way that we just saw. So there's nothing special about this. We just call the function for the component. We call more functions on the structs that are returned. We set the paddings, we set the sizes. We use regular if expressions to determine if something should be shown or not. And we just kind of push these stacks of components together, either in rows or in columns or whatever. The final most interesting thing that I've seen here is the debugger. And this is why we're passing debug in through our entire application here. If we click explain layout, we just get a free bounding box on everything that we've laid out, which is so nice. On the web, I'm used to just like setting every div to have a red border kind of thing, or setting everything to have a red border. But having a button that does this explicitly is really nice, because you can kind of see the space between this checkbox and the explain layout. And you can see the wrapping containers around all of these elements and where they're positioned and how much padding or margin they have, that kind of thing. And of course, if you leave it on, you can go back through this entire thing and see how everything is laid out and where all of these elements go. But that's it for Iced today. I hope you enjoyed this practical tour of Iced. There are a lot of GUI libraries in Rust, more than you might think. So if you've got a favorite that you want me to check out, leave it in the comments and let me know what you think of Iced. Have a great rest of your day.